we will cover the topic of WTF is an analytics lake. Why do we need another sort of water-based data platform to use is what we're going to be covering. So here at GoodData, we are an analytics platform. We've been around for 15-ish years, and about 4 years ago, we set out to re-architect the heart of GoodData to be more composable, more performant, built on open technologies, and of course driven by APIs and SDKs, which is essentially our heritage. And so today we are sharing with you the outcome of that work and teaching you what is an analytics lake and how we have built an open data service layer based on Arrow, DuckDB, and our own semantic layer. And so with that, I will hand it over to Jacek to take it away.
But before I start, I would like to ask you for raising your hand if you have ever built or used a complex, let's say, analytics or BI solution running on top of large data volumes. Is anybody like that here in the room? Okay. And how many of you were satisfied with the performance and basically the responsivity of the tool you used? One. So after the presentation, we should talk with each other because I can't believe that there is somebody like that. So let me talk about how we BI vendors failed in the past completely. Yeah. So on the right side, you can see a dashboard and many spinning wheels, and that's usually what you can see when you use platforms like Tableau or Power BI or even the legacy version of GoodData. Yeah. Let's be honest. Yeah. And even what is even worse, and that's what's painful for me especially because I'm a developer, is the lack of good developer experience. Yeah. So usually when you work with BI platforms or analytics platforms, there are no APIs which are well documented. There are no SDKs. There is no option how to do CI/CD, for example. So this is something what we definitely miss as developers. So let's briefly talk about the GoodData. We are in the BI industry. We have been in the BI industry for a very long time, over 15 years. Many people do not know that we are active in the industry so long, especially because most of our users do not know that they use GoodData. And why? Because GoodData is usually embedded into other software solutions. Yeah. For example, Zendesk is a good example. But there are many other customers, our customers, large customers, who embed GoodData. They white label it. They even do not use our UI. They just call our APIs. And nobody knows. Millions of users do not know that they use GoodData. But the legacy platform, the old platform we have been building for many years, it was very proprietary. Everything was built in-house. Yeah. These were the days where developers wanted to build everything in-house because they know best how to do things. Yeah. And our customers had to move their data to our premise, which was a blocker for many of our prospects. And there was very poor developer experience. Yeah. There were some APIs, but they were not well documented, and the quality of the API space wasn't good. And so 4 years ago, maybe even 5, it's already, I'm not sure. So 4 years ago, we decided to basically restart the whole company and build GoodData platform on Greenfield. Yeah. We used completely different technologies, and we unified our technology stack. So currently, there are only Kotlin microservices and Python microservices and nothing else. We heavily use Apache Arrow. I will be talking about it later. But what's important is that we reuse as much as possible, we reuse open technologies, open source technologies. And we not only use them, but we also actively contribute to these open source projects. What's also different from the former GoodData platform is that you can run it on top of your data warehouse, your database. Yeah. So you don't need to move your data to our premise. That's very important. But is it enough? Well, actually, the answer is no. Yeah. Because when you run responsive analytics on top of data warehouse like Snowflake, sooner or later you realize that when you require very high concurrency, you have thousands or even hundreds of thousands end users, and you are doing it on top of the large data volumes, it doesn't work, and you pay a lot for your data warehouse solution. Yeah. So we are missing something, and that's why so-called Analytics Lake was born in our company, and we believe that as a concept, it should be reused in the industry. So what is Analytics Lake? So we believe that Analytics Lake consists of two parts. The first part is the physical execution itself. So here we are talking about querying data sources, transforming data for analytical use cases like pivoting, for example, and obviously caching. That's a very important part, and that's what's missing. Intelligent caching in the middle between your BI solution and your data warehouse is something we need to provide really responsive analytics. This physical part, we call it FlexQuery. That's a marketing name. I don't like it, but it doesn't matter. And it's actually powered by an engine which is GoodData agnostic. There is no GoodData specific code, and we are even considering open sourcing it. Yeah. So if you would be interested in something like that, do not hesitate to reach our booth and talk with me. Yeah. It's built on top of state-of-the-art open source projects, specifically Apache Arrow and Apache Arrow Flight. And the execution part, the computation part, is powered by DuckDB. Yeah. And then we believe that Analytics Lake should also contain the second part, and that's actually the semantic layer. Yeah. Because when you have semantic layer, you understand your data semantically. You understand the relationships between logical data sets. You understand what is fact and what is attribute, and so on. Then the physical execution I presented in the previous slide can be really intelligent. Yeah. In this case, and what is, I forgot to mention how important is it for self-service. Yeah. So when you want to provide your analytics to thousands or hundreds of thousands business end users who do not know how to write SQL, for example. Yeah. So you want to provide them as safe as possible environment with some kind of drag and drop experience. And it must be safe, which means that when they combine attributes and facts and metrics, the context is taken into account, so they cannot combine things which do not have proper relationship between each other. And that's what we provide for quite a long time, by the way, even in the legacy platform. And recently, we rewrite this engine from scratch as the rest of the platform. And we utilized open source project Apache Calcite for that. And so in this case, credits goes to Julian Hyde, who is leading the Apache Calcite project. So here is the architecture picture. You can see FlexQuery here, surrounded by Analytics Lake, surrounded by an analytics platform. Yeah. And the FlexQuery is responsible for the physical execution on top of data sources, but not only on top of data sources, because not only on top of databases, but, for example, also on top of object storages. And once data are collected efficiently, I will be talking about it later, how efficient it can be. They are streamed to a cache and then post-processed by various data services, which you can implement very easily because it's a part of the Arrow Flight ecosystem. And last but not least, it's even possible to deploy that the third party, our customer, for example, can deploy a custom data service into this stack if he follows the Apache Arrow standard, and he can utilize this custom service, which wasn't built by us in the BI. Yeah. Okay. I would ask you for questions, but maybe it should be in the end.
Yeah, we'll hold it to the end. Yeah.
So obviously, we wouldn't succeed without Apache Arrow. So let's talk a few minutes about Apache Arrow project. Many people think that it's only a format, but this is actually not true. But the format itself is very important. Yeah. So what is the difference, for example, between Arrow and Parquet? Yeah. So the difference is that it's optimized for in-memory processing, which is exactly what you usually do in the last mile before you visualize data. And it's also efficient when you exchange data across the network. Very, very efficient, yeah. Which is exactly the case of FlexQuery, which is obviously scalable horizontally, and you need to exchange data between these data services. Yeah? So you crawl the data, you store Arrow into cache, then you read the cache, and you, for example, calculate pivoting. Yeah? Everything this is efficient thanks to Arrow, and most of the operations are actually zero copy, which is incredible. Yeah? Everything, all the heavy lifting is happening under the hood. And when you take Arrow and create data frame for it, it's zero copy operation in memory. Yeah. But there is much more than the format. Yeah. So for example, the whole framework contains I/O operations with the data, support for I/O operations. There are various converters. You can convert CSV to Arrow, to Parquet, to anything. Yeah. There are drivers for storages like object storages. Yeah. There is Flight RPC API blueprint. Yeah. So it's much easier to build a new data service and plug it into this Arrow Flight ecosystem. And last but not least, there is also a new rising standard Arrow database connectivity, which you can use to crawl data from databases. So it's becoming de facto standard. There is first-class support for Arrow in majority of current data stack. BI tools supported, notebooks supported, databases supported, even Snowflake already supported under the hood in their JDBC driver. I didn't know, but it's even from 2020 year, yeah, so for quite a long time. Okay, so what exactly did we build? So, and what you get out of the box, yeah, if you start using our new FlexQuery. So first of all, there is a cache. You can store arrows in memory, on disk, or in object storages, and you can define very complex rules how data should be promoted or demoted between these tiers. You can define storage classes, and you can isolate workload for your customers, for example. Yeah. And everything this can be configured in a very easy and human-readable way. And there is also CLI for maintaining large deployments. This component is also unique because you can leverage it for pricing. Yeah. So you can define different limits for each customer. You can define tiers for your customers and use it as a leverage. Are your dashboards slow? Pay more for FlexQuery, and we create specific storage class for you with more memory, more computational power, and so on. This is an architecture picture, which is also in an article we just published. So it's horizontally scalable. There is memory, disk mapped to memory, and there can be also durable storage in object storage. Second thing we built for you are data source connectors. When we started building it, we thought that the best option on the market is Turbo ODBC. But unfortunately, we quickly realized that this is not the case. It's quite buggy, even though it's in version 4.11, I think is the latest version. So we changed our mind, and we invested a lot into integrating Arrow database connectivity protocol. Currently, they support only a few databases, but they are actively working on it, and we are thinking even about contributing into Apache Arrow with new connectors. But it works for Postgres, for Snowflake, for important databases, it already works. In this case, we also provide what I call flexible deployment limit enforcement. Managing a lot of database connections can be quite tricky. So here we offer some concept of assigning connections to pods or running instances, basically. So you can dedicate an instance for only Snowflake connections, and you can define maximum number of connections per database type or per customer or per whatever. Yeah. That's quite important. And last but not least, the data source connectors are capable of streaming data into the Flex cache I mentioned in the previous slide. Yeah. Streaming is important here, because you can get first rows much faster into the cache than the whole request is finished. Yeah. Here is just, this was my personal project, so I wanted to test, do a benchmark, and compare JVM with Python ADBC, and with Turbo ODBC as well. So this is a benchmark, and as you can see, the green bar relates to ADBC, and it's the best option. Yeah. Which is quite interesting because it's running in Python, and in JVM I would expect that when I run the benchmark for a long time, Java will win finally, but no. Yeah. And the last part of the FlexQuery is result post-processing, because what you collect directly from the database is usually not what you want to display in dashboard, for example. Yeah. So here we provide a concept of data services for post-processing results collected from the database. We implemented data services for some intelligent sorting and paging, and also for pivoting, which is a very important part of the analytics. Pivoted tables are something what business end users must have. Yeah. And the pivoting is quite complex topic, by the way, because you may need to calculate also subtotals and grand totals, and you may need to sort by subtotals, and it's really complex. Yeah. And at the end of the last year, we had to implement some features for Gartner, which is always painful. So we decided to leverage FlexQuery for that, and in a few days, my colleagues implemented 3 machine learning algorithms, some kind of prediction, clustering, whatever, running on top of the FlexQuery. So you can say in the FlexQuery, collect data from this database, then transform it somehow, and then predict, do some time series prediction. And everything this is just one chain of the commands which is implemented under the hood, and it's exposed to our APIs. And then it can be consumed by our UI applications, but not only, as you will see later. Okay, how much time do we have?
20 minutes.
Jesus Christ, I'm too fast. Okay, so that's good. We will have more time for live demo if it will work. Yeah. So, so now I will show you some screenshots of what is possible with GoodData. But I think this is something what should be possible with any BI or analytics platform. Yeah. So first of all, self-service experience. I already talked about it. So you need some kind of drag and drop experience. You need to have some kind of catalog of analytical objects like facts, metrics, attributes, data dimensions. And users should be able to drag and drop them, create visualizations, create dashboards from them. Yeah. So that's obvious use case. Second use case, obviously today you must talk about AI even though your presentation doesn't relate to AI at all. So we provide AI chatbot, but we provide much more, and I will be talking about it in the end of the presentation. What is more important is this is the first developer experience. So we provide various SDKs for developers, so they can not only embed our dashboarding application, yeah, but they can build completely custom application. Yeah. In this case is some personal project of my colleague Andy. He was excited about the anniversary of Pluto, so he created a completely custom application with a lot of text and some customized visualizations and other active components, just using our UI SDK, and he built it like in a few hours. Yeah. We also provide Python SDK. This is becoming very popular, especially in the area of machine learning, obviously. Yeah. So Jupyter Notebook is just an example. Yeah. I tested it also in DeepNote, for example, because they are also in Prague and they are our friends. You can, in just a few lines of code, you can connect to GoodData, consume the semantic layer, and then you can build a report, yeah, or visualization in Jupyter. But you can follow up with some machine learning stuff and then push the result of the machine learning back to GoodData. That's also possible. And you can either execute already created report or visualization. That's one option. But you can also build a visualization on the fly, specifying what metrics you want to use and how, and what attributes you want to use for slicing and dicing. And you can define also filters, and whatever is supported by our API is accessible here in Python SDK. But we are talking about FlexQuery. So let's talk about the developer experience related to the FlexQuery. So raise your hands who knows what is TPCH. Okay, not that many. Interesting. So TPCH is a benchmark. Like 30 years ago it was invented. Yeah. It's really old, yeah. But it's still heavily used. Yeah. There are other alternatives, TPC-DS, TPC-C for OLTP, and so on. It's some kind of standardized data model. It consists of like 8 tables or 9 tables. And they are defined like 22 queries. And when you execute them against the database, you can compare it with other databases, benchmark basically databases. This is query number 4. It's quite simple aggregation. You calculate count by order priority. But there must exist some record in another table. There is exist statement, or yeah. So it's not that simple, and when you run it on top of quite large data volume, it can be tricky. Yeah. This is how you can execute this query in FlexQuery as a developer. Yeah. Currently only internal, but hopefully if we open source it, anyone will be able to doing it. Yeah. To make it interesting, I decided to put the data to 2 different data sources. One is basically AWS S3, and one is Postgres database. The largest table, the line item is in Postgres, and orders, which is also quite big, but not that big, is in AWS S3. What you can see here is you can define how to crawl the data from each data source. You can define only columns you wanna collect. We can even under the hood push down predicates. And every table data is synced, it's stored, it's streamed into Flex cache. as an arrow table. Yeah. And finally, the SQL, which is defined here in Python, SQL is executed on top of what we crawled from these data sources, and the result is again cached or synced into FlexCache. And then you just execute this definition, and you post-process it. For example, you create a data frame for it, and you create a bar chart in Streamlit. And that's it. You don't need GoodData. Nothing here is GoodData specific. Yeah. So does it really work? We'll see. So here is the code. Here you can see basically the same code which you saw on the slide. But to make it even more interesting, I decided to make it more dynamic. So there are input parameters, the cache key, and start date and end date. So there is some date filter. And all the results are stored in a cache, and the cache path contains the cache key as well as the data filter. So when you change the data filter, you can execute the query on top of what data you already crawled. But when you change the cache key, you have to collect all the data again from the original data sources. And then I created just a simple function which encapsulates the execution with the Streamlit application. Yeah. So here, just to have an idea how the deployment looks like. So everything is running on my laptop. There are many containers running. We heavily utilize etcd, by the way. And the FlexQuery follows the CQRS standard, yeah, basically eventual consistency. Everything is eventually consistent. Yeah. And every request inside FlexQuery sends also some version token. And so when the data are not yet there, we poll, we wait, and then the final result is consistent. Yeah. So let's start the Streamlit application. And does it fail? Actually, I'm lucky. Okay, cool. So this is the visualization of the result of the query. Yeah, just simple bar chart. And now we can change the cache key to data cancel, let's say. And what is currently happening? 6.8 seconds. So in 6.8 seconds, what we did, so we collected, let's say, hundreds of megabytes from AWS S3, respectively from my local Minayo instance. And we collected hundreds of megabytes of data from Postgres. And then we used DuckDB to calculate the final result on top of these arrow tables. And everything this took only 6.8 seconds. And now, when I change the data filter, let's say like that, we have different result, and the execution took 600 milliseconds because we reused the caches, the raw caches, but we had to execute again the final query with DuckDB, and that's really, really fast, even though it's running on top of very large data. Okay, I'm lucky it works. But what is the idea behind? Because this is very simple use case. Yeah. But the idea behind the analytics lake is that you can combine everything this with the semantic layer. Yeah. So you can not only just hard code this use case, but instead, by leveraging the semantic layer, you can build a catalog. And when users will use these entities under the hood, we generate these snippets and execute for the end users everything under the hood. Yeah. And not only that, yeah, we would like also to make the caching more intelligent. So, because we know definitions of reports, and we can create query trees for them because we finally have to generate SQL. So we can detect which pre-aggregations are mostly used by end users. And instead of crawling the raw data, we can crawl only these pre-aggregations. And we can even update them incrementally. And that's the ultimate goal. Okay. So let's get back to the presentation. Slideshow again. A taste of the future. So obviously, guess what will be the topic of the taste of the future? Obviously, AI. What else? What I'm trying to demonstrate here is the composability of the FlexQuery. Actually, we were thinking about to implement this because we knew that it would take just a few hours, but unfortunately, we didn't have time to do it. But it would take just a few hours to implement something like that, because the composability of the whole ecosystem. I could encapsulate the SQL query I presented in the previous slides. I could encapsulate it with something like AI explain. And what would it do? And we actually already have it in the platform, but not implemented in this nice way yet. It would basically took the result, it would send it to the large language model, and large language model would explain the data, and the final result, the data and the metadata with the explain would be sent to the consumer. And this is my idea or my vision how the ultimate architecture combining FlexQuery with AI, how it should look like in the case of GoodData. So there is still FlexQuery with all the data services, but there are also dedicated Gen AI services. And these services are not only directly talking with OpenAI, that's silly, but instead there is a vector database and also graph database for a knowledge graph. And it's populated by not only the semantic layer, but also user behavior. So you know what is used by which user groups, and you can personalize even the experience to end users. And everything this is possible because you implement more robust AI architecture. I'm talking about RAG and multi-shot prompting and all these concepts. We are currently working on that, by the way. So let me summarize everything what I have told here. And also give a credit to my colleague, who is pictured here. Because I wasn't responsible for the whole development of the FlexQuery, but this guy was. So what we offer? So we offer the analytics lake, which means that you can deliver responsive analytics, you can deliver self-service experience to hundreds of thousands of business users, and you also get a very good developer experience. APIs, SDKs, everything. Fully documented, by the way, which is usually quite painful. And we are very open. We are building on top of the open source technologies, projects. So when you decide to leave GoodData even, it may happen. We are here open. We use open data formats. So it's easy to transform data from GoodData to another platform. We provide APIs so you can programmatically convert our semantic layer to different semantic layer. For example, I implemented GoodData DBT plugin, so you can transform DBT models into GoodData semantic layer. But you can do it also in the opposite order if you want. So here we want to be as open as possible. And I would like to emphasize again, we are thinking about open sourcing the GoodData agnostic part of the FlexQuery. So do not hesitate to contact us. Yeah? And that's all. Any final words from you, Ryan?
No, thank you, Jacek. We're just about out of time here, so I will just take questions for the audience. But thank you for presenting that. And as it says here, come and meet with us. We have a booth. We'd love to talk to you about anything you saw here, about the analytics lake. The overall vision is, of course, combining the things you need to build analytics with the semantic information that describes them, right? And that is where the power really comes from. Well, thank you, everybody.